The NESI board has 5 main power drivers, 2 of which control the blue LED bank and the red LED bank, one that controls the gas sensor's heating element, and then 2 other multi-purpose ones. These multi-purpose ones can be accessed at power driver A and power driver B, which on the back are labeled JP2 and JP11 respectively. So for the sake of testing the NESI board, we're going to go ahead and cut off two pin headers from a stack of female headers, and we'll go ahead and solder those onto the board at power driver A and power driver B, so that way we can plug stuff into them without having to solder each individual component in. And then we'll go ahead and we'll solder in the female header to power driver B. So now that we've got those header pins soldered in, we can go and attach a few components here to test the power drivers. When working with power driver B, you must select the voltage. Both 5 volts and 6 volts is available at into power driver B. So in order to do this, you're going to find the location marked JP16 on the back of the board, and on the front of the board it's actually labeled power driver B supply select. So in order to select the voltage, you're going to tie either the 5 volt pin, which is on the right, or the 6 volt pin, which is on the left, to the center pin. So for this particular application, I'm going to go ahead and use the 5 volt pin. So I'll go ahead and tie that to the center pin here with just some jumper wire. So I'll attach the 5 volt pin, which is on the right, to the center pin. And now that I have that jumper in there, I'll go ahead and solder it down. So power drivers A and B are actually slightly different. On power driver B, you can select the voltage, but on power driver A, you actually can get feedback as to whether there's load on the power driver or not. So to demonstrate those functions as well, I'm going to go ahead and plug a motor into power driver A. So the first part of everything that I'm going to do applies to both power driver A and B. But the second part, where I'm going to detect feedback, only applies to power driver A. You can disable the feature of getting feedback by desoldering a resistor up here. I believe it'd be resistor 7, R7, but I'm not going to demonstrate that in this video. So now I have my my motor plugged in, and then I can go ahead and jump to programming it to turn on and off and detect feedback.
Alright, so in order to demonstrate the use of the power drivers, we're going to open up a new project in MPLabX. So once that's opened, we're just going to navigate to the main.c file. And this is the basis of our blank main.c. Again, if you don't know how to make this particular, or something that looks like this, then there will be another video explaining that. So to get started with the power drivers, we're going to go and include that library. So we'll do that. We'll type the # include, and then powerdriver.h. And that's the C header file for the power drivers. This isn't really necessary. This include right here, it isn't very necessary, mainly because when I included NESI.h, it's automatically included in powerdriver.h. So if I actually navigate to NESI.h here, you'll actually notice that powerdriver.h is already included. So it's not really necessary, but for the sake of example, we're going to go ahead and include it. So the initialization for the power driver functions doesn't actually have much code in it, but because it's good practice to include initialization functions, we'll go ahead and include those. So it would be power driver, and then A or B. We're gonna stick with A because we have our motor attached with A, or attached to A, and then we're gonna do init, and then power driver B dot init. So that initializes both of these power drivers, and neither one of these initialization functions takes any parameters. So we can just go ahead and put the 2 parentheses there. So in order to demonstrate the use of the power driver functions, we're going to turn power driver A on. Then we're going to wait for, let's go 3 seconds. Then we're going to turn power driver A off, and then we're going to wait for another 3 seconds. So the on function for the power driver is just power driver and then which power driver using A or B and then on. So we would type power driver A dot on like so, and then for the wait for 3 seconds, I'm going to use the delay function. If you're actually programming something else, I wouldn't recommend using the delay function because it simply halts the program. For that amount of time, it can't do anything else. So you couldn't make it detect a button press during that time, for example. But the function I'm going to use is underscore underscore delay underscore ms, and then the amount of milliseconds you want to delay it for. So 3000 is 3 seconds. And then we're going to turn power driver A off. We're going to do power driver A dot off. And then we're going to wait for another 3 seconds using that delay function. So that's the basis of our code here. We turn the power driver A on, then we delay for 3 seconds, then we turn power driver A off, then we delay for 3 seconds, and then that'll loop over and over again. So it'll go back to the beginning here and turn A on and off and on and off with 3 second increments. So these functions right here, on and off, and the initialization functions will work for both power driver A and B. So you can easily change that to B right there. But because our motor is connected to A, we'll go and use A. There are a few other functions that really only apply to power driver A. They work with power driver B, but it actually doesn't do any good because power driver B doesn't have that feedback as to whether there is or is not, load on the circuit. So one of these functions is failure, is okay, and status. So these 3 functions are only really applicable to power driver A. If we were to run this and compile this right now, it would actually build and it would run just fine. So our build was successful here, but in order to demonstrate that would work right there. But in order to demonstrate the full use of power driver A, we want to use feedback here. So we only want it to perform this if power driver A is working, if something's actually hooked up. So we can do if an if gate here, and then power driver A dot is okay. These two functions, is okay and is failure, are exactly the opposite of each other. If we go up here and we look in the power driver.c file, we can actually see that failure, or that if you call is okay, it just returns the opposite of is failure A. So you can use them interchangeably, more or less. They're just opposites of each other. So you do power driver A dot is okay, and then we'll add some brackets. And then if it is okay, then we want to execute all of this code here. If it's not okay, we want to set it so that it will turn the red LEDs on. So we can go ahead and put an else here, and then we'll go ahead and put LED R dot duty cycle. And then because if it is a fault and those red LEDs turn on, then they won't turn off. So we'll go ahead and add a piece of code that just turns the red LEDs off if the power driver A is working all right. So LED R dot duty cycle 0. And then if we were to build that, it should actually build, and that way it'll only run this code if power driver A has something attached to it. So now that our build is successful, we can go ahead and program our NESI board and see it run.
Alright, so we'll go ahead and program the device by plugging it in to a power source, and then connecting the PIC kit 3. Make sure you connect that the correct way, and then turning it on, and we'll go ahead and hit program. And now it is done programming, and you can tell that the program is working. Well, at least part of it's working because the red LED is on. So it's detecting that power driver A is not okay because something isn't connected to it. But if we attach a motor to it, um, because they're actually in our program, we turned the red LED off after the entire cycle is completed. As soon as I plug this in, it'll begin running, as you can see there. It's actually running, and it'll complete that cycle, and then it'll turn the red LED off. In practice, you probably would put the turning off of the red LED at the beginning of the program. You can see that our program works because this the motor is actually running here, and if we were to unplug it, that red LED will turn on. And then as soon as we plug this back in, it'll start running again, and then after it's finished its cycle, that red LED will turn off. Note that the is okay and is failure function actually end up turning off power driver A. So if you're going to use those, just make sure that that they don't interrupt the flow of your program. So if for example you have power driver A dot on followed by if power driver A dot is failure, it will turn the power driver A right back off. So just make sure you take note of that.